Hello, thanks for taking the time to learn about the power of Fibre Channel Over Ethernet, or FCoE, and how JDSU's Xgig protocol test platform can help you realize full network convergence. We are setting up the demonstrations utilizing JDSU's complete FCoE testing platforms to highlight the features of the FCoE switch that connects the FC SAN to Enhanced Ethernet. The test setup involves a mix of Fibre Channel and Ethernet to create the path from Ethernet to FCoE, to FC, and then back. The test platform will correlate data from end to end and provides the complete picture for the multi-protocol environment. Enhanced Ethernet is the foundation that makes Fibre Channel Over Ethernet a reality. Enhanced Ethernet is based on data center bridging, also called DCB. One goal is to create lossless Ethernet for data traffic, such as FCoE. Another goal is to add capability for dynamic load balancing among various traffic types during congestion and prevent long-term congestion. Priority Flow Control Protocol, or PFC, enables lossless Ethernet required by FCoE in a converged network environment. PFC defines 8 different traffic priorities. Each can be paused individually by issuing one pause frame to the transmission end. Enhanced Transmission Selection Protocol, or ETS, guarantees bandwidth for each priority group when there is congestion of a data link. ETS guarantees minimum bandwidth to critical traffic, such as FCoE, and fully optimized latency performance. Let's take a look at ETS validation and performance testing methodology. The goal is to verify the ETS configuration to ensure critical traffic does not get blocked in an oversubscribed situation. Test setup involves stressing the bandwidth limitation using either the load tester or by oversubscribing with multiple hosts and targets while monitor link traffics. In this case, the test setup uses the oversubscribed method with multiple priority traffic classes. The critical priorities are FCoE and iSCSI DCB, which both guarantee 35% of link bandwidth. Real-time results show that both FCoE and iSCSI DCB are running at about 35% of link's bandwidth each, while LAN traffic is taking up the remaining 30%. The combined link bandwidth shows 1,019 megabytes per second, which indicates saturation. These results verified that the ETS configuration is working correctly. Each workload also is set to go on and off to simulate shift in bandwidth needed. This caused ETS to redistribute bandwidth between traffic classes. We also see how FCoE throughput increased from 345 megabytes to 378 megabytes, while iSCSI DCB increased from 356 megabytes to 426 megabytes. This verified that bandwidth is released for needed I/O as it becomes available. The analyzer can also be used to verify ETS setup and make sure devices are operated within the ETS parameter. This is an example of how the analyzer can display bandwidth allocation for each conversation pair based on traffic PCP classes. Each line on the graph represents a conversation pair based on PCP. Priority flow control validation and performance testing can have the same setup as ETS, but for our case we will be using the load testing method. The goal is to verify PFC protocol to ensure traffic is paused just long enough to ensure that receiver port is not overrun. This test extends coverage to include FCoE and FC traffic. The load tester receiver metric shows how the pause frames slow down throughput. These two metrics demonstrate priority flow control protocol at work. How does PFC work? The switch issues pause requests with specific amounts of hold time. This will cause all I/O to stop. The switch can either allow the pause request to expire or issue pause release to allow traffic to continue. We can see that no I/O between pause request and pause release caused traffic to slow down. Delta time between pause request and pause release can cause I/O throughput to suffer if not managed properly. To monitor pause time, the analyzer can provide a report of the PFC flow control metric. In this example, the average pause time is 54.1 microseconds. FCoE is changing the way data centers are working. Supporting this network convergence, JDSU's Xgig system carries multiple protocols at various speeds and functions to accurately test your FCoE and Converged Ethernet environments. These tools ensure you have the tested metrics and verified protocols to keep your data moving quickly, efficiently, and accurately. Thanks for watching.